Okay, in this video I'm going to do an example problem on modulation formats, and we've got an 8 FSK signal here, and the diagram below here shows the frequency versus time, and so we have our time axis horizontally measured in microseconds, so 0, 1, 2, 3, 4 microseconds, and we have frequency axis here. It's not labeled, but we have an 8 frequency channel plan here for our FSK signal. And it's an 8 FSK signal, and that's why we have 8 frequencies. And so part A asks you, in the space below the word frequency, down here that is, write the data bits this sequence of frequency hops represents, and write your bits above the corresponding symbols. Okay, so what we've got here is we've got this symbol table here that shows, given 3 data bits, what frequency to hop to. Okay, so as the data comes in, we take the data bits 3 at a time, and every time we get 3 data bits, we hop to a new frequency. Okay, and so straightforward to do this. I'm going to find first frequency F5, look it up over here, and it's a 101. Next frequency 1 is a 000. Next hop goes to frequency F4, which is 001. F3 is 011. So I'm looking here, F5, then I look over here to get the 101, put it in. F1, look here, 3 zeros, put the 3 zeros right above that. And I'm trying to stay right above them. Okay, so we have another F4, 001, and F6, 100, and F1, 000, F7 is 110, and so on. F6 is 100, F8, 111, F2 is 010, so pretty easy once you get the hang of it, 011. So there's the sequence of bits, and that's part A of the problem. For part B, it asks what is the modulation rate in baud. Part C asks what is the bit rate in bits per second. And let's do those first. So the modulation rate in baud is also known as the symbol rate, and basically what we're seeing, each of these frequency hops is a symbol. Okay, we've got 8 symbols in our alphabet, and we can see that we have 1 symbol every microsecond. And so what I'm going to do is I'm going to say that the rate of the symbols is 1 symbol per 1 microsecond, and that is 10 to the minus 6 in the denominator, so it comes up to the numerator as 1 e to the 6 symbols per second, or 1 megabaud, where a baud is a symbol per second. Okay, the bit rate in bits per second. Well, we know that the bit rate is m times the symbol rate, where m is the number of bits per symbol. And in our example here, we have 3 bits per symbol. Okay, and so I can just immediately write 3 times 1e6, and I'm going to get 3 times 10 to the 6th bits per second, or 3 megabits per second. Okay, let's see. So notice that I'm putting units on my numbers and being very careful about plugging into the equations only after I've written down the value. Okay, so next part D says, does the symbol table show proper grade coding explain? And in the symbol table here, what we're looking for is we're going to go bit by bit, and we're going to ask, how many changes were there from one frequency to the other. And we can see that there was only one change here in the second bit, one change in the third, one change in the second, one change in the first, from 0 to 1. From 5 to 6, there was only one change in the third bit place. From 6 to 7, only one change in the second place. And finally, from 7 to 8, only one change in the third place. And since there's only one bit difference from adjacent frequencies, we are properly gray coded. Only one bit changes. For adjacent frequencies. Okay, let's see here. And then part E, it says, if due to interference, frequency F4 was mistakenly received instead of F3, how many bit errors would this error result in? Well, and the answer is 1 bit error, and that's due to the gray coding. If we wanted to receive F3, 0, 1, 1, and we got F4, 0, 0, 1, then we'd have exactly 1 bit error, which is this. Gotta be careful over here. This one is the error, okay? That's the bit that was in error. Okay, well, I hope this helps on this problem. Thanks for listening and watching.